to accommodate that we are going to be having a location of a sound as our sort of point to run away from, we can go to our behavior tree and let's go to our Blackboard over here and let's create a vector, a location, and let's call it hostile sound location. And this will be where the sound originates from, that we'll keep track of. In our let's see here, we want to go to, we want to create a context now to find this location. So we'll go to Blueprint and type in environmental query context over here. Select that and we'll call this environmental query context, so EQC determine hostile sound location. It's a mouthful, but anyway, so we know that we will be wanting to return one single location, so this is what we'll choose. And we'll have the querier actor, and we will get a Blackboard, meaning we will get the Blackboard of the querier, this AI that we're running. And from this we can get Blackboard value as vector, and we can now type in make literal name, and going back to our behavior tree, we can, on our Blackboard, we can get the name that we just created, so we get exactly the same spelled name. And we use it for a literal over here. Now, the point of this is that the hostile sound location is a variable or a Blackboard key that could be available on several different Blackboards. For example, we will be making another AI after this, which we'll probably call Soldier. And it will also have a hostile sound location that it can determine. However, it might not be interested to run away from it, but it still might be interested to actually find out where it comes from and then react towards it. So that means that we can actually make use of this context for both of these different things as long as the Blackboards share the same name. So we'll return this result over here. So now we have an environmental query context in which we can make use of a sound. However, since this sound is not going to be known before we actually make it in game, what we can do to just use this as a debugger is we can instead use get actor by class, and then we choose to have the third person character. So the third person character will act as our proxy for the sound being made, and we'll plug it in like so, and we'll get actor location. And this will be our debug information, so to speak, just we can see that it's actually working, right? Going back to our environmental query, we can now say that we want to add a test, and we can say that we want to add the test over here, and we can say distance. So the logic for this is going to be the civilian over here. Oh, that's a lot of points. The civilian over here is going to want to hide, but it's going to be like wanting to hide somewhere really close. So it will be determining points closer to it higher, because it wants to have as short as possible a way to get to some kind of safety. So with that in mind, when we have our test over here, we want to have, instead of a, we can actually make sure that we make sure this is a score only. Then we go out and see in the pawn here, we can see that it's currently scoring the ones further away as higher. So we just go and make it an inverse linear, like so, and that makes it more higher scored when it's closer to the actual pawn itself. the querier. Now in addition to this, we want to filter out all of the points that are not actually interesting, which means all the points that actually have a line of sight to this character. So let's figure that out. We want to add another test, and we want to make it a trace, and we want to trace this towards our environment or our context of our hostile sound location, which is currently going to be our player, but it will later on be our sound. So we want to filter this, and here you have a bool match, and this is essentially you can put in some kind of logic here, and if you're getting the complete opposite of the logic that you're expecting to get, you just uncheck the bool match and you'll have the opposite created for you. So let's see what this looks like then. So now currently we're here, and you can see that all of these blue points have been filtered out, so those are not interested, and we can see all of these other points are the ones that are being shown as valid. Now they're being shown as valid even though they don't maybe make a whole lot of sense, because over here we wouldn't likely be able to hide unless we were a small dwarf or something of that nature. And the reason for this is they are testing against this object over here, which is going to be in the middle of this capsule because that's where its origin point is, in comparison with the origin point of each of these different spheres, meaning that it's very low and along the ground. You can alter this by adding some height to the points. Projection data here, you have a vertical offset. So let's say we wanted to have something, a capsule is, I believe, 180 in height or something. We have a half size on the capsule. So 96 is the half size, 96 is therefore the half of the height of it. So we can actually make use of 96 then. Let's say an even 100. There. This means that everything that is 1 meter up in the air, the player will be able to see from that location. And now if we check here, we can see that some of these points have disappeared. So the closest to the staircase here, he won't be able to see, but over here, the player will not be able to see, and getting there would be the safest point in this case for this pawn, because it is the closest and it's somewhere where you can't see, for example. So that is now the logic for the civilian to get to safety. So now we can go back to our behavior tree. Let's see here. There. And we can run our EQS query here. And it's called... what did we name it? Right, we need to choose an EQS query, and from here we choose the name. So hiding location over here. Now, this in itself will then provide us a different Blackboard key, or a Blackboard key to make use of for where this location is. And the Blackboard key we want to have here could be used as, for example, our wandering location, although we might want to have a completely different one to make sure that they're very easily distinguishable. So if we go to Blackboard key and create a new location, new vector, we call this our hiding location. We'll say we go back and we now tell it that the hiding location is the location it should be setting from this EQS query. And from there we need to, of course, move to that location. So we set hiding location over here, and then we just hide here. Now we might want to have something like this logic running multiple times. If we, for example, were trying to hide against a player that's moving and it comes around the corner, we might want to have a recalculation of where to run and hide again. In our case, since we're just going to go by the sound for this a simple example, it won't make a whole lot of difference. We can still put in a wait here of 1 second so that this logic doesn't run as fast as possible, because remember, a sequence will run through all of its different nodes, and if we only have these 2 nodes, it will run this and then we'll move there, which it will immediately succeed at, and then it will run this again, and we just pump a lot of performance into something that is not really necessary. So wait here can at least diminish that a little bit. We could also have put a decorator here saying that we want to have a cooldown or something like that to make sure that it doesn't do it too often. But this is easily displayed and understood as well. But just different ways that you can do it in. So now essentially we have all of the logic that we want to have the AI to do when it is in its different states. Now, how do we actually make this happen then? Well, we need to go to our blueprint for the civilian. Our blueprint for our civilian has our AI perception inherited, and if you did not follow the earlier episodes, then this is what you need to add. You need to add a component, and you type in perception here, and you add the perception component over here. Once you have that added, you have over here senses configs that you can add, and we have added the sight config and the hearing config. Important to note on both of these are that you need to also check the checkboxes for enemies, neutrals and friendlies to have this work properly. But this allows us at least to react to sights and to sounds for this specific AI. In this case, it won't be making use of the sight sense, but it will be making use of the hearing sense in the form of the sound stimuli. So that's what we need for here. Now we need to have a reaction to the sound. What we will do is we will right click and we'll type perception updated. No, that's not okay. Let's do it this way. We'll have it selected. Add event for AI perception, and we want the one that's called on perception updated. This one. This one will give us an array of actors that have in some way been updated for our stimuli, and we can use this to loop on. Then for each element here, this will be an actor for each then. We can get perception. This means that we'll get all the relevant perception information about this one currently. And we can check here in the info, if we break this, all the perception related information in form of our stimuli arrays, which we in turn can loop on as well to get all the individual stimuli. So if we do it like this, and then we break these, then we get all the specific information about these. Now we will only be reacting to, actually we currently have sight, so we could react to it, but it won't actually matter because we have a decorator saying that we only react on a hostile sound, remember? So if we have successfully sensed is not going to be enough, we will be instead using our tag here to check. Let's see, we have an equal here. So we can check if a tag is a certain value. So this is not the ideal way to do this, especially if you have multiple different tags possibly available. But what we can do here is we can make a hostile sound tag and check against that, which will make it easy for us to just see that we're handling the right stimuli for now. Like so. And we want to also probably, I'm thinking we might get a stimuli that says it is this, but we're not successfully sensing, which means we are not actually interested in reacting to it anymore. So we want to also do this. We want to have an and over here and make sure that both of these are true for us to actually do something about this. Actually, we might want to do it this way. Let's do it first, a branch to check if it is the hostile sound. Let's get rid of this. If it is the hostile sound, then we want to have a different check. We want to check if it's successfully sensed. Because in the case that it is not successfully sensed, but it is the hostile sound, that means that the sound has expired, basically. It happened so long ago that we don't consider it a danger anymore. And then that means that we want to update our Blackboard as well. So in these two cases, we can get a Blackboard. And for these two cases, we want to set a variable. Set Blackboard as bool, which is our boolean that we created earlier, which is in survival mode. Let's see, there. So in the case that we are successfully sensing something that's a hostile sound, then we want to have this boolean set to true. If we are successfully identifying this perception or this stimuli to be a hostile sound, but it is not successfully sensed anymore, we want to set this as false, meaning we go back to our normal state. And then we make literal, and we make sure that we get the same name for these. So, and then we hook that up there as well. So this is how we can communicate. We need to have this one as well. So this is how we will communicate by our perception to our Blackboard that we are in danger, or the civilian is in danger. And then it will start to react to it. But it still doesn't have the location of where is the danger. And this is something we can give ourselves a little bit more space, something we get from the stimulus location here. So we'll add another set value as, and then we have vector. So this will be the position of the sound that we hear, so the gunshots. And this vector is the stimulus location. Like so. And then we need to, of course, also set the name, which in this case is going to be something hostile sound location. Like that. Now, we only need to set this location when we are determining that it's both the sound and we are sensing it. Because other than that, when we are reaching this point, it doesn't really matter. We're not interested in it anymore. So that's why we're only setting it in this case over here. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.